Welcome back. This is C. Aloui. In the last video, we spoke about confidence intervals of a population mean knowing the standard deviation of the population, sigma. In most realistic settings, the population standard deviation is not known. This section shows how to conduct a confidence interval of a population mean. The following slide shows the cheat sheet to conduct a confidence interval by using the t-distribution. Notice that the steps to follow are the same as when using the z-distribution, except step number 2, in which we use the t-table and the degree of freedom, which is the sample size minus 1, to obtain the critical value. In step 3, we calculate the margin of error. And finally, in step 4, we make a concluding statement. Let's work some examples. Let's work the following example. A cereal producer makes cereal boxes with a stated weight of 750 grams. From a large lot of the produced boxes, a random sample of 7 boxes yielded a sample mean of 795.3 grams and a sample standard deviation of 17.8 grams. Pause this video and construct a 95% confidence interval for mu, the mean weight of the boxes in this lot. Let's work through the cheat sheet to find the confidence interval of the mean weight of the cereal boxes. Step 1. Carefully read the problem statement and extract the statistics such as the sample mean and standard deviation, the sample size, and the confidence interval. Don't forget to check the normality in the statement. Step 2. Get the critical value from the t-table or by using Microsoft's Excel. Step 3. Calculate the margin of error, E, as shown. And finally, write a concluding statement while thinking critically about the results. We are 95% confident that the true mean weight of cereal in boxes from this lot lies between 778.8 and 811.8 grams. Let's interpret the confidence interval furthermore. This conclusion applies to this lot only. It is questionable to use the t procedure for such a small sample size. When it is reasonable to utilize the t method. For the t method to be valid, 1. A random sample must be collected by using a good sampling design. 2. Either a normally distributed population or a large sampling size, which will be normally distributed regardless of the population distribution. If n is more than 40 samples, the t procedure works well in most situations. If n is between 15 and 40 samples, the t procedure does not perform well if there is a strong skewness or outliers. If n is less than 15, one should be wary of using the t procedure. When feasible, check the normality assumption with a normal quantile-quantile plot or other methods proposed previously in the textbook. Let's define robustness of a statistical procedure. A statistical procedure is called robust to violations of an assumption if the procedure still performs reasonably well when the assumption is violated. Robustness is a crucially important property for a statistic to have, because in real life, often the assumptions are not completely true. Finally, when we are sampling from a distribution that is not normal, our sample will not be normally distributed in an absolute manner. Let's define the confidence interval procedure for a population proportion. As you can see in the cheat sheet, the 4 steps remain the same, except for an additional check in step 1, and we use the z-table in step 2 to get the critical value. Take a moment to familiarize yourself with this cheat sheet. Let's work an example to find the confidence interval procedure for a population proportion. A sample of 500 nursing applications includes 60 applications for men. Find the 90% confidence interval of the real proportion of men who applied for the positions. Pause the video for a few moments to find the answer. Let's apply the cheat sheet provided in the textbook to solve this example. Step 1. From the problem statement, we have a sample of 60 men having a proportion of 0.12. The product of the sample size and the proportion of men, NP, is more than 5, and 1 minus NP is more than 5 as well. Step 2. The critical value from the z-table is 1.645. Step 3. Calculate the margin of error by using the formula provided. Finally, Step 4. Make a concluding statement. We are 90% confident that the population of male nursing applicants is between 9.61% and 14.39%. At this stage, we are ready to conduct the confidence interval for a population variance by using the chi-square distribution. Have a look at the cheat sheet provided in the textbook shown in this slide. Basically, the same 4 steps while having the chi-square distribution in Step 2, and the confidence interval is calculated differently as shown in Step 3. You may refer to the textbook for further discussion about these steps. Let's do an example on the confidence interval on the population's variance. A sample of 7 boxes of oatmeal with a nominal weight of 750 grams has the weights shown in the table. Find the 95% confidence interval for population variance sigma square. Pause the video and apply the cheat sheet to solve this example. The solution to this problem is very easy if we apply the cheat sheet provided. Start by calculating the sample mean to find 795.2857 grams and the sample variance of 315.5715 grams square. Notice that these values were not directly provided in the problem statement. Then, find the critical value by using the chi-square table and the degree of freedom n-1, and apply the values found in the equations provided. Finally, make a concluding statement like, we can be 95% confident that sigma square, the true variance of weights of oatmeal boxes, lies between 131.0385 and 1,530.2909 grams square. Have a look at this table that summarizes the confidence interval procedures for the population mean. Standard deviation known, use the z-table. Standard deviation unknown, use the t-table. You should check normality in the problem statement. To conduct confidence interval on a population proportion, check the assumptions on the sample mean and use the z-table. Finally, to conduct the confidence interval on the population variance, check normality and use the chi-squared table. Have a look at this diagram that will help you select the right type of confidence interval from a problem statement. Pause the video if you want to look at it for more time. The following slide shows how to use Microsoft's Excel to find the confidence interval using the z-distribution and the t-distribution. Pause the video to run these examples. Let's do a few examples on the confidence interval for the population mean, knowing the population's standard deviation. Pause the video and do the following examples. Let's solve the first question. Just follow the cheat sheet provided in the textbook to easily solve the problem. Step 1. Extract the statistics like the sample mean and the sample's standard deviation, the confidence level, and check the normality. Step 2. Get the critical value using the z-table or by using Microsoft's Excel. Step 3. Calculate the margin of error. And finally, Step 4. Make a concluding statement. Let's do some examples on the confidence interval for the population mean, not knowing the population's standard deviation. This case is more realistic. Pause the video, put the cheat sheet provided in the textbook next to you, and try to solve these questions. The following slide shows the 4 steps to conduct the confidence interval. Step 1. extract the statistics and check normality. Step 2, get the critical value from the t-table or by using Microsoft's Excel. Step 3, calculate the margin of error. Finally, make a concluding statement like the one shown in the slide. Let's do some problems for confidence interval for population proportions. Pause the video for a few minutes to solve these problems. Use the cheat sheet provided in the textbook. Let's solve the first question by using the cheat sheet. Step 1, extract the statistics and check normality. Step 2, get the critical value from the z-table or by using Microsoft's Excel. Step 3, calculate the margin of error. Finally, Step 4, make a concluding statement. For more lessons on descriptive and inferential statistics, check out our textbook, Illustrated Statistics for College Students, available on Amazon. Thanks for watching.